Picture this, a towering marvel of human ingenuity, the Lighthouse of Alexandria, standing proud for centuries until one day, without warning, it crumbles into the sea. The very builders who crafted it would have sworn it was indestructible. Yet here we are, thousands of years later, scratching our heads. How could the greatest minds of antiquity make such colossal mistakes? From misaligned pyramids to temples that defy gravity, ancient engineers left behind puzzles that modern experts still can't solve. These weren't simple oversights. These were jaw-dropping errors, or were they? Some were so bizarre, so seemingly impossible, that they make you wonder if we're missing something bigger. A lost technology, a forgotten secret, or maybe, just maybe, these weren't mistakes at all. Today, we're diving into 25 of the most baffling ancient engineering blunders that have left historians and scientists utterly stumped. Get ready to question everything you thought you knew about the past, because by the end of this video, you'll see these so-called mistakes in a whole new light, and you might just start wondering if our ancestors knew something we don't. Stay tuned, the truth is stranger than you think. Now, let's shine a light on our first mystery, the shocking collapse of the Lighthouse of Alexandria. This wasn't just any structure, it was one of the 7 wonders of the ancient world, a beacon of human achievement towering over 400 feet tall. Built to guide ships safely into harbor, it stood for over 1,600 years until it vanished, leaving behind a question that still haunts engineers today. How could something so meticulously designed simply crumble away? Theories abound, but none fully explain its demise. Some point to earthquakes, a logical culprit in a region prone to seismic activity. But here's the puzzle. The lighthouse survived numerous quakes before its final fall. If it withstood centuries of tremors, why did it collapse when it did? Others blame coastal erosion, suggesting the foundation was slowly eaten away by the sea. Yet records show the structure was repeatedly repaired and reinforced. Wouldn't such advanced builders have noticed a threat as basic as erosion? Then there's the design itself. The lighthouse's architects were masters of their craft, yet modern engineers have stumbled upon baffling choices. For instance, the use of certain materials in key areas defies logic. Some sections were oddly brittle compared to the rest of the structure. Was this a simple oversight, or was there a purpose we've yet to uncover? Even more perplexing are reports that parts of the lighthouse seem to collapse inward, almost as if the weight distribution was miscalculated. But these builders weren't amateurs. They calculated load-bearing stresses with precision in other projects. So why here? Perhaps the most tantalizing clue lies in ancient texts. Some accounts describe a network of mirrors inside the lighthouse, capable of reflecting sunlight to incredible distances. Could these have altered the structure's integrity over time? Or was the collapse not a mistake at all, but the result of something far more deliberate, a lost technology or even sabotage? The more we examine the evidence, the less it adds up. This wasn't a haphazard failure. It was a flaw that defies the very expertise of the people who built it. And that's what makes the Lighthouse of Alexandria's collapse not just a historical tragedy, but a genuine enigma. One thing's for sure, the answers, if they're ever found, might rewrite what we think we know about ancient engineering. Next up, we'll turn our attention to another iconic structure that defies logic, the Leaning Tower of Pisa. But this time, the mystery isn't why it fell. It's why it's still standing. Shifting our gaze from the fallen beacon of Alexandria, we arrive at a marvel that stubbornly refuses to fall, the infamous Leaning Tower of Pisa. This architectural rebel, defying gravity for over 800 years, poses a paradox. Its very flaw is what keeps it standing. But how did this medieval misstep become one of history's most enduring accidents? The trouble began before the first stone was laid. The tower's foundation, a mere 3 meters deep, was dug into soft, unstable ground, a mixture of clay, sand, and shells. To make matters worse, the soil wasn't uniformly dense. The south side sank almost immediately under the weight of the marble, causing the tilt we see today. Builders tried to compensate by making the upper floors slightly taller on the sinking side, but this only added more weight to the fragile foundation. By the time they reached the third level, the lean was undeniable. Construction halted for nearly a century as Pisa's engineers grappled with their mistake. When work resumed, the tower's savior might have been its very incompetence. The long pause allowed the soil to compact naturally, stabilizing the structure just enough to prevent collapse. Later architects added the iconic bell chamber, deliberately built off-center to counterbalance the tilt. But here's what baffles modern experts. Today, with all our technology, we couldn't recreate this perfect mistake if we tried. The lean, now roughly 4 degrees, exists in a precarious equilibrium. Any attempt to replicate it would likely result in either immediate collapse or no tilt at all. The soil itself is part of the mystery. Modern simulations show that Pisa's subsurface behaves unpredictably, with moisture levels causing subtle shifts. In the 1990s, engineers stabilized the tower by carefully removing soil from beneath the north side, reducing the lean by half a degree, but they admitted the process bordered on guesswork. One wrong move and the tower could have toppled. Perhaps the most startling revelation: the lean isn't static. The tower actually dances, shifting millimeters with the seasons as groundwater levels change. Medieval builders, oblivious to hydrogeology, accidentally created a structure that moves with the earth rather than against it. This unintentional harmony with nature might be why it still stands while perfect modern buildings sometimes fail. So next time you see that famous tilt, remember, this isn't just a botched job. It's a testament to how chaos and genius sometimes intertwine. And that brings us to our next enigma, a wonder so elusive some doubt it ever existed at all. The Hanging Gardens of Babylon await. Now, let's wander into the realm of botanical wonders, or perhaps botanical illusions. The Hanging Gardens of Babylon, one of the 7 wonders of the ancient world, are shrouded in a mystery so thick even their existence is debated. Described as a lush, terraced paradise rising above the arid plains of Mesopotamia, these gardens were said to defy nature's harshness with an intricate irrigation system. Yet here's the puzzle: despite centuries of searching, archaeologists have found no physical trace of them in Babylon. No ruins, no inscriptions, not even a single broken pipe. How could something so grand vanish without a whisper? The gardens were first documented by Greek historians like Strabo and Diodorus Siculus centuries after their supposed construction. According to these accounts, King Nebuchadnezzar II built them in the 6th century before the Common Era to soothe his homesick wife, who missed the green mountains of her homeland. The descriptions are vivid tiered gardens dripping with exotic plants, supported by stone columns, and fed by an elaborate system of screws, pumps, and aqueducts lifting water from the Euphrates River. But here's the catch: Babylonian records from Nebuchadnezzar's reign mention none of this. Not a single cuneiform tablet celebrates this engineering feat. Modern excavations in Babylon reveal impressive structures, the Ishtar Gate, the Ziggurat Etemenanki, but nothing resembling the gardens. Some theorists suggest the confusion stems from a mistranslation or a mix-up with another site, like Nineveh, where Assyrian King Sennacherib boasted of a sophisticated irrigation network for his own gardens. His system used Archimedes' screws centuries before Archimedes supposedly invented them, to channel water from distant mountains. Could the Greeks have conflated the two? Then there's the irrigation conundrum. Even if the gardens existed in Babylon, how did they sustain such verdant life in a desert? The Euphrates lies below the city's elevation, meaning water would need to be lifted nearly 50 meters, a staggering task for ancient technology. The Greeks described a chain pump, but no remnants have been found. Some proposed terracotta pipes or shadows, yet these leave no trace in the archaeological record. Perhaps the most compelling argument against the garden's existence is Babylon's water table. The region's soil is saturated with salt, which would have poisoned the plants within years. No ancient texts mention the constant replanting such a disaster would require. So, were the Hanging Gardens a poetic exaggeration, a lost marvel, or a case of mistaken identity? Until evidence surfaces, this wonder remains a ghost in the historical imagination, a testament to how easily myth can weave itself into history. And speaking of precision defying logic, let's turn to another enigma: the Great Pyramid's strangely misaligned chambers where perfection seems to have slipped through the cracks. Now, shifting our gaze from botanical mysteries to towering stone enigmas, we arrive at the Great Pyramid of Giza, a monument so precise, its construction still baffles engineers today. Yet, buried within its near-flawless geometry lies a curious anomaly: the misaligned chambers. How could a civilization celebrated for their mathematical mastery make such uncharacteristic errors? The Great Pyramid, built for Pharaoh Khufu around 2,600 years before the Common Era, is a marvel of alignment. Its base is level to within just 2 centimeters, and its sides are oriented almost perfectly to the cardinal directions. But step inside and the narrative falters. The King's Chamber, the Grand Gallery, and the so-called relieving chambers above them are slightly but unmistakably off-center. The King's Chamber, for instance, sits about 20 centimeters east of the pyramid's central axis. This might seem trivial, but for builders who routinely achieved precision within millimeters, it's a glaring inconsistency. One theory suggests these mistakes were intentional. The misalignment could mirror the imperfection of the human world compared to the divine perfection of the gods. Alternatively, some researchers propose that the chambers shifted over millennia due to seismic activity or settling. But here's the catch: the pyramid's outer casing stones, many of which are now gone, were placed with such accuracy that even a knife blade couldn't slip between them. If the exterior could withstand shifting, why not the interior? Another puzzle is the Queen's Chamber, which lacks the grandeur of the King's Chamber and sits even further off-axis. Its purpose remains debated, but its misalignment is harder to dismiss as symbolic. Recent scans reveal hidden voids and corridors around it, hinting at unfinished or repurposed spaces. Could the pyramid's design have changed mid-construction, forcing last-minute adjustments? Then there's the Grand Gallery, a soaring passageway with a corbelled ceiling that ascends at a precise 26-degree angle, except it isn't perfectly straight. Its walls wobble slightly, as if the builders corrected course during construction. This contradicts the Egyptians' reputation for meticulous planning. Were they rushing, or did they encounter unforeseen structural challenges? Modern laser scans show that the pyramid's internal passages also deviate slightly from true north. Some experts argue this aligns with the star Thuban, which was Earth's pole star in Khufu's time. But if so, why aren't other chambers adjusted similarly? The most compelling clue might lie in the pyramid's construction techniques. Researchers like engineer Peter James propose that the inner chambers were built using a series of stepped platforms, with each layer slightly misaligned due to the limitations of ancient leveling tools. Over time, these tiny errors compounded. Yet this doesn't explain why the exterior remains flawless while the interior drifts. So, were these misalignments accidental, symbolic, or evidence of a lost construction method? Until we uncover more, the Great Pyramid's imperfections remain a silent challenge to our understanding of ancient engineering. And speaking of ancient secrets, our next stop takes us to a material so durable, it puts modern science to shame: the uncrackable mystery of Roman concrete. Now, turning from the riddles of stone to the secrets of mortar, we encounter one of antiquity's most stubborn puzzles: Roman concrete. This isn't just any building material. While modern concrete cracks and crumbles within decades, Roman harbors submerged in seawater for over 2,000 years remain intact. Scientists have studied its composition for centuries, yet the full recipe, especially its resistance to erosion, still eludes replication. How did the Romans achieve such immortality in their structures, and why can't we match it today? The magic lies in the mix. Roman concrete combined volcanic ash, lime, and seawater, creating a chemical reaction modern labs struggle to mimic. The key ingredient, pozzolanic ash from the region of Pozzuoli near Naples. When mixed with lime and seawater, it forms a mineral called aluminum tobamorite. This crystal, found in ancient samples but rarely in modern concrete, reinforces the material over time, making it stronger with exposure to salt water. Modern concrete, by contrast, weakens in marine environments due to corrosive salts. The Romans didn't just build for their era, they built for eternity. But here's the twist. We've known the basic recipe since at least the 1st century before the Common Era, thanks to writings by architect Vitruvius. So why the replication crisis, the devil's in the details? Modern attempts often fail to capture the precise ratios, curing conditions, or even the granularity of the volcanic ash. Recent studies reveal that the Romans likely mixed their concrete hot, triggering a faster chemical bond, while today's methods rely on room temperature mixing for convenience. The result, a material that's convenient but far less durable. Another clue emerged in 2017, when researchers discovered that seawater percolating through Roman concrete actually repairs tiny cracks by forming new minerals. It's a self-healing property modern science can't yet engineer at scale. Imagine a breakwater that patches itself, no maintenance crew required. The Pantheon's dome, still the world's largest unreinforced concrete dome after nearly 2,000 years, owes its survival to this very phenomenon. Yet the mystery deepens. Not all Roman concrete was equally resilient. Structures built inland using freshwater instead of seawater lack the legendary durability of coastal ruins. This suggests the saltwater wasn't just an accident, it was a calculated ingredient. Some researchers even speculate that the Romans understood the alchemy better than we've credited, tweaking recipes for specific environments. The implications are staggering. If we could reverse engineer this technology, it could revolutionize seawalls, nuclear waste storage, even space colonization. But for now, the full formula remains locked in the past. Perhaps the real error wasn't the Romans, it's ours for assuming antiquity's methods were primitive. Their concrete stands as a silent rebuke to modern shortcuts, and as we unravel its secrets, we're reminded that some ancient mistakes weren't mistakes at all. Up next, another defiance of physics, the Mycenaean Lion Gate, where a massive lintel has balanced precariously for millennia, daring gravity to do its worst. Now, shifting our gaze from the secrets of Roman concrete to the marvels of Mycenaean masonry, we arrive at one of history's most baffling structural paradoxes, the Lion Gate. Crowned by a colossal limestone lintel weighing roughly 20 tons, this entrance to the ancient citadel of Mycenae shouldn't still be standing. By all laws of physics, that massive slab should have crumbled under its own weight millennia ago. Yet here it is, defying gravity for over 3,000 years. How does it cling to stability while appearing so perilously unbalanced? The answer lies in the Mycenaeans' cunning understanding of weight distribution. At first glance, the lintel seems to hover precariously above the gate's entrance, supported only by two slender upright stones. But look closer. The builders carved a subtle triangular relief above the lintel, dispersing the load outward along the walls rather than letting it press straight down. This ingenious design channels stress away from the center where cracks would typically form. Modern engineers call it a relieving triangle, and it's a trick the Mycenaeans mastered long before the concept had a name. But the Lion Gate's resilience isn't just about clever geometry. The limestone itself holds clues. Unlike later civilizations that prized uniformity, the Mycenaeans embraced the natural imperfections of their stone. The lintle's slightly uneven texture acts like a built-in shock absorber, allowing microscopic shifts during earthquakes without fracturing. Compare this to modern precision cut blocks, which often fail under seismic stress because they can't flex. The Mycenaeans didn't just build, they collaborated with the stone's natural properties. Then there's the matter of the famous Lion Chinese letter, or rather, the lack of one. The two lionesses flanking the central column aren't just decorative. Their missing heads, once thought to be lost to time, may have been intentionally omitted. Researchers now speculate the heads were separate bronze additions, slotting into grooves still visible today. This modular design would have allowed the Mycenaeans to adjust the sculpture's weight as needed, fine-tuning the gate's balance over centuries of settling. Perhaps the most startling revelation, the lintel isn't perfectly level. It angles fractionally downward toward the outside, a mistake that actually redirects rainwater away from the gate's base. This small tilt prevents erosion that could undermine the foundation, a detail modern laser scans only confirmed in recent years. So was it luck or genius? Neither. The Mycenaeans' real breakthrough was humility. They didn't fight nature's chaos, they worked with it. Where we might see a precarious overhang, they saw a dialogue between stone and sky. And while today's engineers calculate load-bearing capacities to the millimeter, the Lion Gate whispers an older truth. Sometimes the best way to defy physics is to listen to them. Next, we journey to Peru, where the Nazca Lines stretch across entire valleys with impossible precision, no aerial view required. Leaving behind the stone mastery of the Mycenaeans, we now turn our attention to one of archaeology's most visually stunning riddles, the Nazca Lines. Etched into the arid plains of southern Peru, these enormous geoglyphs stretch across nearly 1,000 square kilometers, depicting animals, plants, and geometric shapes so vast they can only be fully appreciated from the sky. Yet here's the twist. The Nazca culture crafted these designs between 200 before the Common Era and 600 of the Common Era, millennia before human flight. How did they achieve such staggering precision without ever seeing their work from above? The scale alone is mind-bending. The hummingbird glyph spans over 90 meters, its wings perfectly symmetrical. The spider stretches 50 meters, each leg proportioned as if drawn with a ruler. Even the spirals and trapezoids, some stretching hundreds of meters, maintain crisp, unwavering edges. Modern recreations using GPS and drones struggle to replicate their accuracy. Yet the Nazca people managed it with rudimentary tools and no aerial perspective. Archaeologists have uncovered some of their methods, but each answer sparks new questions. They likely used simple ropes and wooden stakes to plot measurements, removing reddish surface pebbles to expose lighter soil beneath. But precision at this scale requires more than basic tools. Researchers found small-scale sketches on pottery matching the larger designs, suggesting the Nazca first perfected proportions in miniature before scaling up. Think of it like a painter gridding a canvas, except their canvas was an entire desert. The real mystery lies in how they maintained alignment across such vast distances. Without sightlines from above, even a minor angle miscalculation would distort the entire figure over hundreds of meters. Some theories propose they used constellations or mountain peaks as guides, while others suggest they built rudimentary observation platforms. Yet no evidence of such structures exists. The most compelling clue: many lines converge at ceremonial mounds, hinting at a ritual purpose that may have dictated their flawless execution. Then there's the enigma of preservation. These lines have survived for 2,000 years with minimal erosion, thanks to the region's unique climate, windless days, and annual rainfall measuring mere millimeters. But the Nazca couldn't have predicted this stability. Did they stumble upon the perfect canvas by accident, or did they understand their environment well enough to exploit it? Perhaps the most haunting question is why. Unlike monuments meant to impress, the Nazca Lines are invisible from the ground. Some argue they were pathways for religious processions, while others believe they were offerings to gods or markers for water sources. Their purpose may remain debated, but their craftsmanship is undeniable. These weren't careless scribbles, they were calculated marvels, a testament to human ingenuity without modern technology. As we marvel at these desert puzzles, remember, the Nazca Lines challenge our assumptions about ancient capability. They didn't need drones or satellites to achieve perfection, just patience, creativity, and an intimate dialogue with the land. Next, we descend into the depths of Turkey, where the Derinkuyu underground city's ventilation system defies logic. Descending from the sky-high mysteries of the Nazca Lines, we now venture deep beneath the earth to confront an underground marvel that defies logic, the Derinkuyu underground city. Carved into the soft volcanic rock of Turkey's Cappadocia region, this labyrinthine city plunges 18 stories down, housing thousands of people, their livestock, and even places of worship, all while maintaining breathable air for centuries. How did an ancient civilization engineer such a vast subterranean space without suffocating its inhabitants? The answer lies in a ventilation system so advanced it rivals modern design. At first glance, Derinkuyu's existence seems impossible. The city dates back to at least the 8th century before the Common Era, with some sections possibly older. Its tunnels stretch over 8 kilometers, with rooms stacked like a honeycomb, reaching depths of 85 meters. But the real shocker, the air inside remains fresh even at the lowest levels. Ancient engineers achieved this by crafting over 50 ventilation shafts, some as narrow as 10 centimeters in diameter, threading vertically through the rock like lifelines. These shafts connected to the surface, creating a natural airflow system that pulled stale air up and drew fresh air down, a primitive but effective form of air conditioning. What's baffling is the precision of these shafts. Unlike crude holes, they were strategically placed to exploit differences in air pressure and temperature. Cooler air from the surface sank into the lower chambers, while warmer air rose and escaped through higher vents, creating a continuous circulation. Even more impressive, the shafts were disguised or protected from invaders, some hidden within chimneys or wells. This wasn't accidental design, it was deliberate, sophisticated engineering. Then there's the question of scale. Modern simulations show that maintaining airflow in such a deep, expansive network would require precise calculations. Too few shafts and the air would stagnate, too many and the system would lose efficiency. Derinkuyu's builders struck a perfect balance, but without any known tools for measuring air pressure or flow. Some researchers speculate they used smoke trails to test drafts, while others believe they observed natural cave systems for inspiration, yet no surviving records explain their methods. Equally puzzling is how they prevented toxic gases from accumulating. With thousands of oil lamps burning and animals housed underground, carbon monoxide should have been deadly. But the shafts doubled as exhaust systems, funneling out fumes while bringing in oxygen. Even the city's communal kitchens, equipped with massive stone hearths, had dedicated vents to channel smoke upward. This level of foresight suggests an understanding of air quality that shouldn't have existed in antiquity. Derinkuyu's purpose only deepens the mystery. Was it a refuge from invaders, a permanent settlement, or a sacred space? The city's sheer size, capable of sheltering 20,000 people, implies meticulous planning, but who orchestrated it? And why invest such effort in an invisible feat of engineering? Unlike pyramids or temples, ventilation shafts don't inspire awe, they simply keep you alive. As we resurface from this underground enigma, one truth lingers. Derinkuyu's builders didn't just survive underground, they thrived. Their invisible masterpiece challenges our assumptions about ancient innovation, proving that some of history's greatest engineering triumphs are the ones we can't even see. Next, we journey to the high Andes, where the Sacsayhuaman Wall's seamless joints mock modern stonemasonry. Leaving the depths of Derinkuyu behind, we now ascend to the towering heights of the Andes, where the Sacsayhuaman walls stand as a silent challenge to modern engineering. These massive stone fortifications, perched above the ancient Inca capital of Cusco, are a masterpiece of precision that defies logic. Each boulder, some weighing over 100 tons, fits so perfectly against its neighbors that not even the thinnest blade can slide between them. No mortar, no gaps, just an unshakable embrace of stone against stone. The scale alone is staggering. The outermost walls zigzag across the hillside like the teeth of a colossal stone serpent, with some blocks rising twice the height of a grown man. But it's the seams between these stones that truly baffle experts. Unlike typical masonry, where gaps are filled with binding material, the Inca builders shaped each block to interlock with its neighbors like a three-dimensional puzzle. The surfaces aren't just flat, they curve slightly, creating a subtle tension that locks the stones in place. This technique, known as ashlar masonry, is so precise that earthquakes over centuries have failed to topple them, while Spanish colonial buildings nearby crumbled. How did the Inca achieve such perfection without iron tools, wheels, or even a written language? The prevailing theory involves a painstaking process of trial and error. Stones were likely shaped by pounding them with harder rocks, then sanded with abrasives until they matched a wooden template. But this doesn't fully explain the consistency. Some blocks have as many as 12 angles, all fitting flawlessly. Modern engineers using laser scans have found that the deviations between stones are less than half a millimeter, a level of accuracy rivaling today's machine-cut materials. Even more perplexing is the transportation. The quarries for these stones lay over 20 miles away across rugged mountain terrain. Without draft animals or wheels, moving these megaliths would have required an army of laborers, yet there's no evidence of ramps or sledges. One hypothesis suggests the Inca used a system of ropes and log rollers, combined with carefully engineered inclines, to walk the stones into place. But how they lifted blocks weighing dozens of tons onto walls remains unsolved. Then there's the purpose. While Sacsayhuaman is often called a fortress, its layout suggests something more ceremonial. The zigzag walls may have symbolized lightning, a sacred motif in Inca cosmology. The precision then wasn't just functional, it was spiritual. Every seamless joint was a testament to the harmony between human labor and the divine. As the sun sets over these indomitable walls, one question lingers. Why invest such effort in invisible perfection? Unlike ornate carvings or towering statues, the genius of Sacsayhuaman is hidden in the negative space between stones. It's a reminder that ancient engineers didn't just build for glory, they built to last. Next, we cross the Pacific to confront the silent giants of Easter Island, where the Moai statues pose a riddle of their own. Now, let's journey from the intricate walls of Sacsayhuaman to the windswept isolation of Easter Island, where the towering Moai statues stand as silent sentinels of an ancient mystery. These colossal stone figures, some weighing as much as 80 tons and reaching heights of 30 feet, dot the island's coastline, their blank stares fixed inland as if guarding secrets lost to time. But the real enigma isn't just their imposing presence, it's how they got there in the first place. Easter Island, or Rapa Nui, is one of the most remote inhabited places on Earth, a tiny speck in the Pacific over 1,000 miles from the nearest shore. Yet, between the 9th and 17th centuries, the Rapa Nui people somehow transported nearly 900 of these massive statues from the quarries at Rono Raraku, where they were carved, to platforms called ahu scattered along the coast. The distance wasn't trivial. Some statues were moved over 10 miles across rugged terrain, without the use of wheels, draft animals, or even abundant timber for sledges or rollers. For decades, experts debated how this was possible. Early theories suggested the statues were dragged horizontally on log sledges, but this raised another problem: Easter Island's deforestation. By the time European explorers arrived, the island was nearly treeless, with no evidence of the vast forests needed to support such a method. Another idea proposed that the moai were walked upright, rocked back and forth by teams pulling on ropes, a theory popularized by experiments showing it could work with smaller replicas. But critics argue that this method would have been dangerously unstable for statues weighing dozens of tons, especially on uneven ground. Then there's the question of the roads. Archaeologists have mapped ancient pathways radiating from the quarries, some with clear grooves or wear marks. Yet these paths don't always lead directly to the Ahu, and many are uneven or steep, complicating the idea of a standardized transport system. Even more puzzling, dozens of moai were abandoned along these routes, some buried up to their necks in soil, as if the effort to move them was suddenly halted. Was it due to warfare, resource collapse, or simply a shift in priorities? The statues themselves add another layer of intrigue. Many moai wear pukao, cylindrical stone, hats made of red scoria, a lighter but still massive material quarried from a different site. How these were lifted atop the statues, some already weighing 40 tons, remains a mystery. Some researchers suggest ramps made of earth or stone, but no physical evidence of such structures has been found. Perhaps the most haunting question is why? Why invest so much labor in creating and moving these monoliths? The prevailing view ties the moai to ancestor worship, with each statue representing a revered lineage. But the scale of the effort hints at something deeper: a society willing to pour generations of labor into a project with no obvious practical benefit. It's a reminder that ancient engineering wasn't just about function, it was about meaning. As we leave the moai's silent gaze, we head next to the shores of ancient Greece, where a device so advanced it seems out of place in history. The Antikythera mechanism challenges everything we know about ancient technology. Now let's set sail from the enigmatic shores of Easter Island to the sunken treasures of the Mediterranean, where a discovery so astonishing it rewrote history lay hidden for 2,000 years. In 1901, off the coast of the Greek island of Antikythera, divers stumbled upon the remnants of a shipwreck. Among the statues and artifacts was a corroded lump of bronze and wood, something so unassuming at first glance that it was nearly overlooked. But when researchers painstakingly cleaned and examined it, they realized they were holding what's now called the Antikythera mechanism, a device so advanced it defies everything we thought we knew about ancient technology. This intricate assembly of gears, dials, and inscriptions, dating back to around the 1st century BCE, is often dubbed the world's first analog computer. Its purpose: to predict celestial events with astonishing precision. The mechanism could track the movements of the sun, moon, and planets, foretell eclipses, and even mark the timing of Olympic Games, all through a complex system of at least 30 interlocking bronze gears, some thinner than a coin. What's baffling is that nothing remotely this sophisticated appears again in the historical record for over 1,000 years. The medieval astronomical clocks of Europe, often hailed as marvels of their time, seem rudimentary by comparison. How did the ancient Greeks achieve this? The mechanism's design hints at a deep understanding of astronomy, mathematics, and precision engineering far beyond what historians believed possible for the era. The gears employ a differential turntable, a component so advanced it wasn't thought to have been invented until the 19th century. The inscriptions on its surfaces are essentially a user manual, detailing how to read its predictions, evidence that this wasn't a one-off experiment but a refined tool, possibly mass-produced for scholars or wealthy patrons. The mystery deepens when we ask who built it. While no signature survives, experts speculate it could be linked to the legendary mathematician Archimedes or the renowned astronomer Hipparchus, both of whom lived just centuries earlier. But here's the twist. The Antikythera mechanism's craftsmanship suggests it wasn't the work of a lone genius, but rather part of a broader tradition of Greek mechanical engineering, a tradition lost to time. No other examples have survived, likely due to the perishable nature of bronze, which was often melted down for reuse. Perhaps the most haunting question is why this knowledge vanished. The Roman Empire's rise shifted priorities from scientific inquiry to military and infrastructural projects, and key techniques may have been lost in the chaos of wars and dwindling academia. By the time the medieval world began rediscovering gearwork, the Antikythera mechanism's brilliance was a forgotten echo. Leaving behind this ancient enigma, we turn our gaze to the colossal stones of Baalbek, where another engineering marvel or mistake defies explanation. Now let's journey from the intricate gears of the Antikythera mechanism to the sheer brute force of the Baalbek megaliths, a site where size and scale defy logic. Nestled in modern-day Lebanon, the ancient ruins of Baalbek boast some of the largest stones ever handled by human hands. Among them, 3 colossal blocks known as the trilithon, each weigh an astonishing 1,000 tons. That's heavier than 3 fully loaded Boeing 747 jets. But here's the kicker: these stones were lifted and fitted into place with such precision that modern engineers still can't replicate the feat using the technology believed to have existed 2,000 years ago. The mystery begins at the quarry, just half a mile from the main temple complex. Here, a single block nicknamed the Stone of the Pregnant Woman lies abandoned, partially carved from the bedrock. This monolith dwarfs even the trilithon, weighing an estimated 1,200 tons. How did ancient builders intend to move something this massive? Theories range from wooden rollers to levers and pulleys, but none fully explain how they could have transported it uphill without the stones crushing their own supports. Even today, the world's strongest cranes struggle to lift objects half this size. What makes Baalbek even more baffling is the precision of the trilithon's placement. These stones form the foundation of the Temple of Jupiter, stacked 20 feet above ground level with joints so tight you can't slip a sheet of paper between them. The Romans, who later built atop these megaliths, credited their construction to a race of giants, a telling admission of their own inability to explain them. Modern archaeologists, however, trace the blocks to an earlier civilization, possibly the Phoenicians, though no records survive to confirm how they achieved this. One prevailing theory suggests the use of counterweight systems or a ramp network, but no evidence of such infrastructure has been found. Another idea points to advanced lost techniques, like sound levitation, a concept hinted at in some ancient texts but dismissed as myth by mainstream science. The truth might lie in a combination of simple machines and sheer manpower, coordinated on a scale we've underestimated. Yet, even if thousands of workers drag these stones, the logistics of aligning them perfectly remain a puzzle. The Baalbek megaliths stand as a humbling reminder that ancient engineers may have possessed knowledge we've yet to rediscover. As we move from these impossible weights, our next stop takes us to a marvel of the opposite extreme: the Great Wall of China, where durability seems to follow no consistent rule. Now, shifting our focus from the immovable giants of Baalbek, let's turn to a structure that stretches beyond the horizon: the Great Wall of China. This iconic marvel, spanning thousands of miles, is often hailed as a triumph of ancient engineering. Yet, beneath its legendary reputation lies a baffling inconsistency. Some sections stand strong after 2,000 years, while others crumbled within centuries. What explains this stark contrast in durability? Take the Ming Dynasty portions, built between the 1400s and 1600s. These walls, constructed with bricks and mortar reinforced with sticky rice flour, remain remarkably intact. The rice flour acted as a natural adhesive, creating a bond so resilient that even modern scientists struggle to replicate its strength. But travel further back in time to the Han Dynasty walls, built over 1,000 years earlier, and you'll find sections reduced to little more than eroded mounds. Why did these earlier walls, often made of compacted earth and gravel, fail so spectacularly? One theory points to regional differences in material quality. Builders in the north, where resources were scarce, often relied on rammed earth, which eroded quickly under heavy rain and wind. Meanwhile, southern sections benefited from stone foundations and kiln-fired bricks. But this doesn't fully explain why some rammed earth segments, like those in Gansu province, outlasted their brick counterparts. Local climate plays a role. Arid regions preserved walls better than humid ones, but even that doesn't account for every anomaly. Another puzzle lies in the construction techniques themselves. Some sections feature intricate drainage systems to divert rainwater, while others lack even basic safeguards. Labor conditions varied wildly too. Historical records suggest some workers mixed mortar with poor quality water or rushed construction under tight deadlines, leading to weak spots. Yet, the most perplexing failures occur in areas where no obvious shortcuts were taken. Was there a lost method or unrecorded innovation that some builders knew and others didn't? Even more intriguing are the myths surrounding the wall's weakest sections. Folklore claims that cursed or hastily built stretches, like those allegedly constructed over the bones of deceased laborers, crumbled first. While these tales are dismissed by scholars, they highlight the enduring mystery. Why does a structure so meticulously planned in parts appear so haphazard in others? As we move forward, this inconsistency forces us to reconsider what we know about ancient engineering. The Great Wall isn't a single project but a patchwork of triumphs and failures, each revealing a piece of a larger puzzle. Next, we'll descend into the hidden chambers beneath Teotihuacan, where another architectural enigma waits sealed doors with no clear purpose. Now, let's venture beneath the surface to unravel another ancient enigma, the sealed chambers hidden deep within the Pyramid of the Sun at Teotihuacan. This colossal structure, one of the largest pyramids in Mesoamerica, dominates the skyline of the ancient city, yet its most baffling secrets lie buried in darkness. While most pyramids in the region were designed with ceremonial spaces, altars, or burial chambers, the tunnels and rooms beneath Teotihuacan's pyramid were deliberately sealed off, their purpose lost to time. Why would builders go to such lengths to conceal these spaces, and what were they hiding? The mystery begins with the pyramid's construction. Built around 200 CE, the Pyramid of the Sun stands over 200 feet tall, its massive weight supported by a foundation of loose volcanic rock. But beneath this unstable base, archaeologists discovered a network of tunnels and chambers, some filled with strange artifacts, obsidian blades, jade figurines, and even liquid mercury. The most perplexing detail, these spaces weren't just abandoned, they were meticulously sealed with rubble and clay, as if to ensure no one could ever access them again. This defies typical Mesoamerican practices, where tunnels often linked sacred spaces or served as passageways for rituals. One leading theory suggests these chambers held something too dangerous or sacred to leave exposed. Liquid mercury, found in small pools beneath the pyramid, was considered a substance of the gods by later cultures like the Aztecs, who associated it with the underworld. Could the Teotihuacanos have sealed these tunnels to contain its toxic power or to guard a spiritual secret? Another clue comes from the alignment of the tunnels. Unlike the pyramid's precise orientation to celestial events, the chambers twist unpredictably, almost as if they were designed to confuse or deter intruders. Yet, the most puzzling aspect is the lack of human remains or ceremonial offerings. In other Mesoamerican pyramids, hidden chambers often housed royal tombs or sacrificial deposits. Here, there's no evidence of either. Some researchers propose the chambers were used for acoustic rituals, their shape amplifying sound in ways we still don't fully understand. Others believe they were time capsules, sealed to preserve knowledge for future civilizations. But if so, why leave no instructions or markings? The sealed chambers of Teotihuacan challenge our assumptions about ancient engineering. Unlike the Great Wall's inconsistencies, which stem from material flaws, this mystery feels intentional, a choice to erase rather than preserve. As we move forward, we'll examine another civilization that defied expectations, the Olmecs, whose colossal stone heads were transported across impossible distances without wheels or beasts of burden. How did they achieve such a feat? The answer lies buried in the jungles of Mexico. Now, shifting our focus from the sealed chambers of Teotihuacan, we find ourselves facing yet another head-scratching marvel, the colossal stone heads of the Olmec civilization. These towering sculptures, some weighing as much as 20 tons, stand as silent witnesses to an engineering puzzle that still baffles archaeologists today. Carved from solid basalt, each head bears unique facial features, suggesting they might portray powerful rulers or deities. But here's the twist: the nearest source of this volcanic rock lies over 60 miles away from where the heads were discovered. How did the Olmecs transport these massive monuments across dense jungles, rivers, and uneven terrain without the use of wheels, metal tools, or even domesticated animals to pull them? The mystery begins with the basalt itself. Quarried from the Tuxtla Mountains, the stone was likely extracted using primitive tools like stone hammers and wedges, a painstaking process that would have required immense manpower. But the real challenge was moving these monolithic heads. Unlike the Egyptians, who used sledges and ramps to transport stone blocks, the Olmecs left no clear evidence of their methods. No roads, no rollers, and no depictions of the process exist in their art. Some theories suggest they might have used log rollers or rope systems, but the swampy, forested landscape of the Gulf Coast would have made such techniques nearly impossible. One compelling hypothesis revolves around water transport. Researchers speculate that the Olmecs could have floated the stones along rivers using rafts or barges, a method later employed by the Maya. However, even this theory has gaps. Basalt is incredibly dense, and sinking a 20-ton head would have been disastrous. Plus, many of the heads were placed far from navigable waterways, meaning they'd still need to be dragged overland for the final leg of the journey. Another clue lies in the Olmec social organization. These heads weren't just artistic endeavors, they were symbols of power, likely commissioned by rulers to assert their authority. This suggests a highly coordinated society capable of mobilizing hundreds, if not thousands, of workers. Some experiments have shown that with enough manpower, teams could have dragged the stones using woven fiber ropes and wooden sledges. Yet, even this would have required an astonishing level of logistical planning, especially in a region prone to floods and mudslides. What's even more puzzling is the lack of intermediate artifacts. If the Olmecs were moving these heads over such vast distances, where are the broken or abandoned ones? Where are the tools or temporary supports that would have been used? The absence of such evidence implies a level of precision and success that seems almost supernatural by today's standards. The Olmec heads challenge our understanding of ancient innovation. Unlike the misaligned chambers of Teotihuacan, which hint at intentional secrecy, this enigma revolves around sheer logistical prowess. Next, we'll journey to Cambodia, where the temple complex of Angkor Wat sank into the earth despite its builders' advanced hydraulic engineering. How could a civilization so skilled in water management fail to prevent its greatest monument from collapsing? The answer lies beneath the shifting soil. Moving from the colossal mysteries of the Olmec heads, we arrive at another architectural enigma, the sinking temples of Angkor Wat. This sprawling Cambodian complex, built as a spiritual and political center of the Khmer Empire, was designed with astonishing precision. Its builders mastered hydraulic engineering, creating an intricate network of canals, moats, and reservoirs to manage the region's monsoon-heavy climate. Yet, despite their expertise, large sections of the temple began sinking into the earth, tilting walls and cracking pavements in ways that defy logic. How could a civilization capable of taming water fail to keep its greatest achievement from collapsing? The answer lies beneath the surface, literally. Angkor Wat sits on a base of soft, sandy soil, a stark contrast to the sturdy laterite and sandstone used in its construction. modern studies reveal that the temple's massive weight, combined with seasonal flooding, caused the ground to compact unevenly. But here's the baffling part. The Khmer engineers knew this. Their sophisticated water management system, including the vast West Barre Reservoir, was designed to stabilize the water table and prevent erosion. Yet, over centuries, the very system meant to save the temple may have accelerated its sinking. Experts point to two critical oversights. First, the canals, while brilliant for irrigation and flood control, may have inadvertently channeled water under the temple's foundation, washing away fine sediments and creating voids. Second, the sheer scale of Angkor Wat structures. Some walls stretch over half a mile, meant that even minor subsidence in one area could trigger cascading failures. Unlike smaller temples where shifts could be absorbed, Angkor's interconnected design made it vulnerable to chain reactions. Recent laser surveys, known as LiDAR, have uncovered something even stranger. The Khmer might have expected the sinking. Some corridors and galleries were built with slight upward curves, as if anticipating future settlement. This suggests a level of foresight rarely seen in ancient engineering. But if they predicted the problem, why didn't they fix it? One theory argues that the subsidence was intentional, a symbolic representation of Mount Meru, the sacred cosmic mountain in Hindu mythology, slowly descending into the earth. Yet, practical challenges remain. The Khmer lacked modern geotechnical tools to measure soil density or predict compaction rates. Their reliance on labor-intensive methods, like packing earth with manual tamps, couldn't counteract the sheer weight of sandstone blocks stacked 5 stories high. Even today, with advanced technology, restoring Angkor's sunken sections is a delicate dance between preservation and intervention. What makes this mystery so compelling is its irony. The same water that nourished the empire's rice fields and filled its majestic moats also undermined its foundations. Angkor Wat's subsidence isn't just a lesson in engineering. It's a reminder of how even the most advanced civilizations grapple with nature's unpredictability. Next, we'll cross continents to ancient Greece, where the Parthenon's architects employed intentional flaws to achieve visual perfection. How could errors create harmony? The answer lies in the eye of the beholder. Shifting our gaze from the sinking temples of Angkor Wat, we arrive at one of history's most cunning architectural deceptions, the Parthenon. At first glance, this ancient Greek masterpiece appears flawless, a monument to precision and symmetry. But look closer and you'll discover something extraordinary. Every seemingly straight line is a carefully crafted illusion. The Parthenon's architects didn't just build a temple, they engineered a visual trick that has stunned experts for centuries. How could intentional mistakes make a structure more perfect? The answer lies in the art of bending reality. The Parthenon's columns, for instance, aren't perfectly straight. Each one swells slightly in the middle, a technique called entosses. To the naked eye, this curvature makes the columns appear straighter than they actually are, counteracting an optical illusion where straight lines can look concave when viewed from a distance. The temple's base also curves upward at the center, rising about 2 inches higher than the edges. This subtle arc prevents the platform from appearing to sag under the weight of the massive structure. Even the columns tilt inward just 2 inches, creating a sense of dynamic balance. These aren't errors, they're strokes of genius, correcting how the human eye perceives scale and proportion. But why go to such lengths? The Greeks understood that mathematical perfection didn't always translate to visual harmony. Without these adjustments, the Parthenon might have looked rigid or distorted, especially under the bright Athenian sun. The architects prioritized how the temple would feel to those standing before it, not just how it measured on paper. This approach defied the rigid rules of engineering, embracing artistry over absolute precision. The most baffling part, these refinements were calculated without modern tools. The builders relied on geometric ratios and an intuitive grasp of perspective, achieving effects that even today's architects struggle to replicate digitally. Some scholars argue the Parthenon's proportions align with the golden ratio, a mathematical relationship found in nature, though debate lingers. What's undeniable is that every floor serves a purpose. Even the spacing between columns varies slightly to account for their position in the colonnade, ensuring uniformity from every angle. Yet the Parthenon's illusions raise a deeper question. Did the Greeks know something we've forgotten? Modern architecture often prioritizes function over form, sacrificing visual elegance for efficiency. The Parthenon, by contrast, reminds us that beauty lies in the interplay of perception and reality. Its designers wielded imperfection as a tool, crafting a temple that feels alive, a testament to human ingenuity's power to outwit even the limits of the eye. As we peel back these layers of deception, our next stop takes us to Petra, where engineers carved an entire city into cliffs only to overcomplicate its water system. Why build channels with impossible precision in a desert? The answer flows from necessity to obsession. Now, let's journey from the sunlit illusions of the Parthenon to the windswept cliffs of Petra, where ancient engineers took water management to an almost obsessive extreme. In the heart of Jordan's desert, this rose-red city thrived against all odds thanks to a water system so precise it borders on over-engineering. But here's the puzzle. Why carve channels with micrometer-level accuracy in a place where mere functionality should have sufficed? The answer reveals a civilization that refused to let the harsh desert dictate its ambitions. Petra's survival hinged on its ability to harness every drop of water in a region where rain was scarce and unpredictable. The Nabateans, masters of hydraulic engineering, didn't just build canals, they sculpted them. Their channels wind through cliffs with gradients as shallow as 1 degree, ensuring water flowed steadily without erosion or stagnation. Some sections were lined with ceramic pipes, others carved directly into rock, all fitted so tightly that leakage was nearly impossible. Even the slightest miscalculation in slope could have spelled disaster, yet their system operated flawlessly for centuries. But here's where it gets baffling. Many of these features exceed practical necessity. Take the ornate carvings along certain channels or the painstakingly smoothed interiors, details that served no clear hydraulic purpose. Modern engineers might call it overkill, but the Nabateans seemed driven by something beyond utility. Was it pride, a display of technical prowess, or perhaps a cultural reverence for water, transforming functional infrastructure into sacred art? The scale of their work only deepens the mystery. Petra's system stretches for miles with reservoirs, cisterns, and even a monumental fountain, the Nymphaeum, fed by gravity alone. One theory suggests the Nabateans over-engineered to future-proof their city, anticipating population growth or climate shifts. Yet others argue their precision reflects an almost spiritual relationship with water, treating it as a divine gift too precious for careless handling. What's undeniable is that Petra's waterworks outshine even Rome's famed aqueducts in efficiency. While the Romans prioritized scale, the Nabateans achieved perfection in miniature, controlling water with a finesse that still astounds hydrologists today. Their system didn't just function, it sang a symphony of stone and fluid in perfect harmony. As we marvel at Petra's hydraulic artistry, our next stop takes us even further into the unknown. The blue stones of Stonehenge, hauled across a staggering distance for reasons that defy logic. What drove ancient builders to move mountains literally when simpler solutions lay at hand? Now, shifting our gaze from the desert marvels of Petra to the misty plains of southern England, we encounter one of archaeology's most stubborn riddles, the mystery of Stonehenge's blue stones. Why would Neolithic builders lug 80 massive stones, each weighing up to 4 tons, over a grueling 140 miles, when perfectly usable materials lay nearby? This isn't just a question of logistics, it's a window into ancient minds willing to defy practicality for reasons we're still unraveling. The blue stones, named for their bluish hue when wet, came from the Preseli Hills in Wales. Modern experiments show moving them would have required sledges, rollers, and armies of laborers, all coordinating across treacherous terrain, rivers, valleys, and dense forests. The effort is staggering, especially when Salisbury Plain, where Stonehenge stands, had abundant sarsen stones. So why the extra mile, or rather, the extra 140? One theory points to the bluestone's perceived sacredness. Geological studies reveal they originated near ancient springs and healing sites in Wales, hinting at a spiritual connection. Were they believed to hold magical properties? Cultures worldwide transport sacred objects over great distances. Think of Mecca's Black Stone or Jerusalem's Temple Mount rocks. But unlike those examples, Stonehenge's builders left no written records, leaving us to piece together their motives from scant clues. Another angle examines the journey itself. Some archaeologists argue the act of moving the stones was a ritual, a test of communal endurance symbolizing unity or devotion. Indigenous traditions like Australia's Aboriginal songlines weave geography and spirituality together. Could the Bluestone's route have been a Neolithic songline imbued with meaning? Yet this raises more questions. Why not choose a shorter path? Excavations show the stones weren't transported directly. They likely meandered, even doubling back at points. Then there's the puzzle of the stone's arrangement. Unlike Stonehenge's towering sarsens, the bluestones were placed in tight clusters, almost like a hidden inner circle. Recent scans reveal they were frequently rearranged over centuries, suggesting their purpose evolved. Were they oracle stones, healing amulets, or ancestral totems? The lack of wear or tool marks deepens the enigma. They show little sign of active use. What's clear is that the bluestones weren't chosen for durability. They weather faster than local sarsens, requiring constant maintenance. This wasn't efficiency, it was intentional obsession. Perhaps the answer lies in a lost myth, a hero's journey, a god's decree, or a simple truth that to these builders some things were worth the impossible effort. As we leave the windswept mystery of Stonehenge, our next stop plunges us into toxic intrigue, the mercury rivers of Qin Shi Huang's tomb, where ancient ambition literally flowed with liquid metal. How and why did an emperor command a substance so deadly to mimic the waters of eternity? Now, from the windswept enigma of Stonehenge, we descend into a tomb of liquid peril. The legendary mercury rivers of China's first emperor, Qin Shi Huang. This isn't just a tale of opulence, it's a death-defying feat of engineering that mingles ambition with toxicity. How did an ancient civilization harness mercury, a substance lethal to the touch, to create shimmering waterways beneath the earth, and why would they risk it? Historical texts describe the emperor's tomb as a microcosm of his empire, complete with miniature palaces, star-studded ceilings, and rivers of flowing mercury mimicking the Yangtze and Yellow River. Modern scientific surveys confirm staggering mercury levels in the soil around the unopened tomb, some areas with concentrations 50 times higher than normal. Yet here's the puzzle: mercury vaporizes easily, and chronic exposure causes tremors, madness, and death. How were thousands of workers shielded during construction? One clue lies in the tomb's design. Sima Qian, an ancient historian, wrote that artisans rigged mechanical traps to deter looters, including crossbows and pits. Could they have also engineered airtight chambers or ventilation systems to contain the mercury? Han Dynasty inventors had already crafted intricate bellows and piping for metallurgy. Perhaps they funneled vapors upward, away from workers, or used layered seals like the wax-lined vessels found in other Qin-era sites. But no physical evidence survives, leaving us to reverse engineer their methods. Then there's the mystery of sourcing. Mercury occurs naturally as cinnabar, a red ore used in pigments and elixirs. Qin Shi Huang famously drank mercury-laced potions, believing they'd grant immortality, an irony that likely killed him. To fill his rivers, miners would have needed tons of cinnabar, yet no large-scale mining traces have been found near the tomb. Did they haul it from distant provinces, or was there a lost purification technique that left no waste? The purpose of these rivers deepens the intrigue. Some scholars argue they weren't just symbolic, they were part of a spiritual engine. Taoist alchemy linked mercury to the life force Kai, and its reflective surface may have been meant to repel evil spirits. Others suggest a more practical angle. Mercury's density could have powered mechanical marvels like the tomb's alleged self-playing instruments, but the greatest enigma is the silence. Despite Mercury's volatility, no mass poisonings are recorded. Workers' bones near the site show no telltale signs of heavy metal poisoning. Were protective measures that effective, or did the emperor's successors erase the evidence? Modern excavations hesitate to open the tomb, fearing both collapse and toxic exposure. As we step back from this gilded death trap, we're left marveling at the extremes of ancient ingenuity and the price of immortality. Next, we'll confront a celestial misstep high in the Andes, the Tiwanaku Gate's solstice misalignment, where the heavens and human hands failed to agree. From the toxic rivers of Qin Shi Huang's tomb, we journey now to the windswept heights of the Andes, where another ancient riddle stands frozen in stone, the Tiwanaku Gate. Carved from a single monolithic block, this towering structure is often called the Gateway of the Sun, revered as a celestial calendar aligning with the cosmos. Yet here's the twist: when modern researchers measured its orientation, they found a glaring error. The gate's astronomical markers don't match the solstices it was supposedly designed to honor. How could a culture so precise in their stonemasonry fitting blocks with laser-like accuracy make such a fundamental miscalculation? The Tiwanaku civilization flourished over 1,000 years ago near Lake Titicaca, mastering agriculture, architecture, and astronomy. Their gate is adorned with intricate carvings, including a central figure believed to represent the sun god Viracocha, flanked by winged attendants and celestial symbols. For decades, experts assumed the gate's alignment marked the June and December solstices, critical dates for planting and harvest. But when anthropologists used 3D mapping, they discovered the gate's sightlines were off by roughly 2 degrees. In astronomical terms, that's a massive error equivalent to celebrating New Year's Day in early February. So what went wrong? One theory blames seismic shifts. The Andes are among Earth's most active tectonic zones, and earthquakes over the centuries could have tilted the gate. Yet nearby structures like the Kalasasaya Temple remain aligned correctly, undermining this idea. Another possibility: the gate wasn't a calendar at all. Some researchers argue its carvings depict a mythological event, not an astronomical guide. The sun god figure might symbolize a creation story, with the gate serving as a spiritual threshold rather than a practical tool. But the most compelling clue lies in the Tiwanaku's own decline. By the time the Inca encountered the site, it was already abandoned. Could the gate have been left unfinished or hastily adjusted during a period of crisis? Soil samples reveal the region suffered a catastrophic drought around the year 1000, potentially scattering the civilization's experts. Without master astronomers to oversee construction, later builders might have misaligned the gate, embedding their desperation in stone. Modern indigenous groups like the Aymara offer a different perspective. They've long used the gate for ceremonies tied to the Wilka Kuti, or Return of the Sun, a festival marking the winter solstice. To them, the error isn't a mistake but a deliberate choice, a reminder that the cosmos operates beyond rigid human measurements. Perhaps the gate's true purpose was always symbolic, blending science with spirituality in a way modern scholars are only beginning to decode. As we stand before this enigmatic portal, its misalignment whispers of a civilization caught between the stars and the soil, their intentions as layered as the Andes themselves. Next, we'll sail to the shores of ancient Carthage, where a redundant harbor design defies all logic and challenges our understanding of naval supremacy. Leaving the enigmatic gate of Tiwanaku behind, We now set our sights across the Mediterranean to the ancient shores of Carthage, where a maritime mystery defies naval logic. This legendary city, once the rival of Rome, boasted a harbor so peculiar that even today, historians scratch their heads. Imagine a naval base with not one but two identical circular harbors side by side, mirror images of each other. In an era where efficiency dictated military design, why would Carthage double its infrastructure without clear purpose? Carthage harbor was the heartbeat of its empire, a masterpiece of maritime engineering described by ancient historians like a paean as unparalleled in the world. At its peak, it sheltered hundreds of warships with an inner military harbor ringed by docks and an island fortress at its center. But the puzzle lies in the outer commercial harbor, a second, equally massive circle connected by a narrow channel. Both harbors shared the same dimensions, depth, and layout, a redundancy that seems baffling for a civilization known for its ruthless pragmatism. Experts have wrestled with theories. Was it a failsafe? If one harbor was blocked or sabotaged, the other could still function. Yet no records mention such an attack, and Carthage's enemies never breached its coastal defenses until the final Punic War. Another idea suggests the dual harbors separated fleets by class, perhaps trading vessels in one, warships in the other. But artifacts show both basins housed military ships, mixing tactics with trade. The most tantalizing clue comes from a faded Carthaginian ledger, hinting at a cultural divide. One harbor for Phoenician-born commanders, the other for local recruits. If true, it reveals a society so deeply stratified that even its docks echoed social hierarchies. The Romans, who eventually razed Carthage, were equally perplexed. After conquering the city, they preserved the harbor's design in their own naval bases, yet never replicated the twin-circle layout. Modern engineers note that maintaining two identical basins would have doubled dredging costs and repair labor, a drain on resources with no tactical advantage. Satellite scans reveal something even stranger. The harbor's foundations align with celestial patterns, much like Tiwanaku's gate. Could Carthage sailors have used the twin circles as a navigational aid, mirroring stars to guide night voyages? Perhaps the answer lies in Carthage's downfall. When Roman legions finally stormed the city, they reported fires raging in one harbor, while the other remained eerily untouched. Was the second basin a decoy, a hollow boast of naval might meant to intimidate enemies? Or did its builders, like the Tiwanaku, embed a hidden purpose lost to time? Today, the harbor's remnants lie beneath the modern city of Tunis, their twin circles still whispering of a maritime enigma as deep as the Mediterranean itself. Next, we'll ascend to the cloud forests of Peru, where earthquake-proof stones defy the very laws of physics and rewrite the history of ancient engineering. Now, let's journey high into the Andes, where the ancient Inca crafted a fortress in the clouds, one that laughs in the face of earthquakes. Machu Picchu, perched precariously on a mountain ridge, has endured for centuries without a single crack in its mortar-free walls, while modern buildings around the world crumble under seismic force. How did a civilization without steel or cement achieve what our engineers still struggle to replicate? The secret lies in the stones themselves. Unlike conventional masonry, the Inca didn't rely on mortar to hold their walls together. Instead, they carved each block with mind-bending precision, fitting them together like a jigsaw puzzle. These aren't just snug fits, they're engineered with deliberate imperfections. The slight angles and uneven surfaces allow the stones to shift during tremors, absorbing and dispersing energy like a shock absorber. When the ground shakes, the walls dance rather than fracture. Modern seismic experts call it ashlar masonry, but even they admit the Inca perfected it beyond modern capability. Take the Temple of the Sun, Machu Picchu's architectural crown jewel. Its curved walls are constructed with stones so meticulously shaped that not even a credit card can slide between them. Yet during earthquakes, these stones ripple like a wave, settling back into place once the tremor passes. Engineers have tried to mimic this with flexible joints in contemporary buildings, but none match the Incas' natural solution. The kicker: the Incas had no written language or advanced measuring tools. They achieved this precision through intuition and generations of stoneworking mastery. Even more baffling is how these stones were transported. The granite used at Machu Picchu was quarried miles away across treacherous terrain. Without wheels or draft animals, the Inca likely dragged these multi-ton blocks uphill using logs and ropes. But here's the twist: the stones at the base of structures are larger and more angular, while those higher up are smaller and smoother. This wasn't random. It created a center of gravity so low that even violent shaking couldn't topple the walls. Modern high-rises use similar principles with reinforced bases, yet Machu Picchu's structures predate Newton's laws of motion by centuries. The ultimate test came in 1950 when a magnitude 7.5 earthquake struck the region. Nearby Cusco saw colonial-era buildings collapse, but Machu Picchu, not a single stone was displaced. Seismologists now study the site to improve earthquake-resistant designs, but the Incas' techniques remain elusive. Some theories suggest they tested their walls by simulating tremors with logs or water, while others believe they observed how natural rock formations weathered quakes. Either way, their knowledge was so advanced that even today we're left reverse engineering their mistakes, except in this case there were no mistakes. From Carthage's redundant harbors to Machu Picchu's dancing stones, ancient engineers continue to humble us. Next, we'll unravel an even older enigma: a 12,000-year-old temple with carvings too advanced for its time. But now, let's turn back the clock even further, to a time before pyramids, before written language, before even the invention of the wheel. Nestled in the rolling hills of modern-day Turkey, Göbekli Tepe shatters everything we thought we knew about the dawn of civilization. Dating back an astonishing 12,000 years, this prehistoric temple complex shouldn't exist. Its towering limestone pillars, intricately carved with lions, scorpions, and vultures, display a level of artistry and precision that defies the timeline of human development. How could hunter-gatherers who hadn't yet mastered farming or pottery engineer such a sophisticated site? The mystery begins with the sheer scale of the project. Each pillar at Göbekli Tepe weighs between 7 and 10 tons, quarried from bedrock over 300 meters away. Without metal tools, beasts of burden, or even settled agriculture to sustain a workforce, how were these massive stones extracted, transported, and erected? Archaeologists once assumed megalithic structures like Stonehenge required the organization of an advanced society, yet here's Göbekli Tepe, built millennia earlier by nomadic tribes. The pillars aren't just stacked, they're locked into place by carefully carved grooves and sockets, a technique so advanced it wouldn't reappear until the Bronze Age, some 6,000 years later. Then there's the artistry. The reliefs on these pillars aren't crude scratchings, they're masterful depictions of animals, rendered with anatomical accuracy and dynamic poses. The craftsmanship rivals that of much later civilizations like the Assyrians or Egyptians, who had centuries of cultural evolution behind them. Even more puzzling, many of these carvings were intentionally buried shortly after completion, sealed under layers of soil as if hiding a secret. Some researchers speculate these weren't just decorative, but served a ritual or astronomical purpose, perhaps tracking celestial events with a sophistication we'd only expect from cultures with written records. But perhaps the greatest enigma is what Göbekli Tepe implies about human progress. Conventional history tells us that complex societies emerged after agriculture, as farming allowed surplus food and specialized labor. Yet here, it seems the reverse happened. The temple came first and farming followed. Pollen samples from the site suggest the people of Göbekli Tepe may have cultivated grains nearby, hinting that organized religion, not survival needs, drove the invention of agriculture. It's a theory that flips the script on human development, suggesting spirituality, not just practicality, shaped our evolution. Modern tools like ground-penetrating radar reveal that less than 5% of the site has been excavated, with potentially 20 more monumental circles still buried. What other revelations lie beneath the soil? For now, Göbekli Tepe stands as a humbling reminder. Our ancestors were far more capable and far more mysterious than we ever imagined. Next, we'll examine another ancient head-scratcher. The Indus Valley's missing tools were a thriving civilization left behind no trace of how they built their precision-engineered cities. Moving from the enigmatic carvings of Göbekli Tepe, we arrive at another ancient puzzle that leaves archaeologists scratching their heads, the baffling case of the Indus Valley's missing tools. This sophisticated civilization, thriving over 4,000 years ago in what is now Pakistan and northwest India, built sprawling cities with grid-like streets, advanced drainage systems, and uniform brick constructions. But here's the catch: despite their remarkable engineering feats, almost no tools have been discovered to explain how they achieved such precision. The uniformity of their bricks alone is staggering. Across multiple cities like Mohenjo-Daro and Harappa, bricks were standardized to a ratio of 4 to 2 to 1, with dimensions so consistent they suggest mass production. Yet, unlike the Egyptians or Mesopotamians who left behind chisels, saws, and drills, the Indus Valley people seemingly built their marvels with invisible tools. Where are the hammers to shape the bricks, the axes to cut timber for scaffolding, the molds to ensure each brick matched the next? It's as if their technology vanished without a trace. One theory suggests their tools were made from perishable materials like wood or bone, which decayed over millennia, but that doesn't fully explain the precision of their masonry. The edges of their bricks are sharp, the corners perfectly squared, details that typically require metal or stone tools. Another possibility is recycling. Perhaps tools were repurposed or melted down, leaving no surplus behind. Yet even recycled tools leave traces like workshop debris or fragments, and these are conspicuously absent. Then there's the mystery of their stonework. Indus Valley artisans carved intricate seals from steatite, a soft stone depicting animals and script with fine detail. But how? No engraving tools have been found, and the seals show no signs of trial and error mistakes. Some researchers propose they used copper or bronze tools, yet metal objects from the era are vanishingly rare. Even more puzzling, their cities show no evidence of quarries or kilns, raising questions about where and how materials were sourced and processed. The absence of tools isn't just a gap in the archaeological record, it challenges our understanding of their society. Without clear evidence of workshops or specialized labor, how did they maintain such high standards? Did they possess knowledge lost to time, or is the answer buried deeper, waiting to be uncovered? For now, the Indus Valley's missing tools remain one of history's quietest yet most perplexing riddles. Next, we'll wrap up our journey through these ancient engineering enigmas, reflecting on what they reveal about the ingenuity and mysteries of our ancestors. And so, as we bring our journey through these 25 ancient engineering puzzles to a close, one thing becomes undeniably clear: our ancestors were far more advanced and far more enigmatic than we often give them credit for. From the towering missteps of the Lighthouse of Alexandria to the silent absence of tools in the Indus Valley, each mystery peels back another layer of what we think we know about the past. These aren't just isolated blunders or oddities. They're profound reminders of how much history remains unwritten, how many techniques and technologies have been lost to time, and how even the most brilliant minds of antiquity could stumble in ways that still baffle us today. Consider the sheer diversity of these enigmas. The Romans mastered concrete that outlasts modern versions, yet we can't fully replicate their recipe. The Egyptians aligned the Great Pyramid's chambers with celestial precision, except for those few that mysteriously deviate. Easter Island's Moai statues were transported across miles without wheels or beasts of burden, while the Nazca Lines were etched into the desert with geometric perfection, all without a bird's eye view. Each case defies simple explanations, forcing us to question whether these were mistakes at all, or if we're simply missing a piece of the puzzle. What binds these mysteries together isn't just their unresolved nature. It's the way they expose the limits of our modern assumptions. We tend to view ancient civilizations through the lens of our own technology, assuming they must have struggled where we excel. But these engineering oddities suggest otherwise. Perhaps the mistakes weren't failures but experiments. Maybe the missing tools were intentionally hidden or so commonplace they've been overlooked. The past doesn't always conform to our expectations, and that's what makes it so endlessly fascinating. Now we turn to you. What do you think happened to the Indus Valley's tools? How did the builders of Sacsayhuaman fit stones together without mortar, yet so tightly you can't slip a blade between them? History is a conversation, and your theories are part of it. Share your thoughts in the comments below. Let's unravel these riddles together. And if you're hungry for more historical head scratchers, don't forget to hit that subscribe button and ring the notification bell. From lost technologies to architectural wonders that defy logic, there's always another mystery waiting to be explored. Thanks for joining us on this journey through the past's greatest engineering enigmas. Until next time, keep questioning, keep wondering, and keep digging into the stories that shape our world.